cosmic ray density is higher than the galactic average in the galactic center, for example, suggesting a source of freshly accelerated protons in the region. But we may have to wait for observations from the next generation of Cherenkov detectors to help solve the strange mystery of HAWC J1746-2856. Well, there it is. You have to be an astrophysicist to be really into that. But nevertheless, it just goes to show some of the most interesting things are on our astronomers' desks and what they're really getting their teeth into. So I bless their hearts with all the excitement that it must bring them, especially when you've got amazing scientific instruments at their hands, both in orbit and in space, as well as ground-based, to be able to perform some of these amazing research they're doing. I really wish I was there right next to them. Anyway, there it is. This is VK3EKH, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast. Okay, now, let's see, how quick does this article go for? It's just another 5 minutes. All right, this might segue into Tanya's video clip, courtesy of space.com. And we're talking about the sun again. Watch sun unleash major X-flare in epic solar eruption video. Well, I don't have this video. I don't know. They didn't really include the video in this article. We could expect even more eruptions from the sunspot region in coming days as it rotates to face the Earth. And I think Tamitha is going to be talking about this. The sun has been rather quiet of late, but since roared back to life with a major X-class solar flare eruption, the most powerful class of solar flare. The intense solar flare originated from sunspot region AR3869 and unfolded over a span of an hour, reaching its peak at 11:57 p.m. EDT on October 23rd. Extreme ultraviolet radiation from the eruption triggered shortwave radio blackouts over Australia and Southeast Asia. The eruption was accompanied by a coronal mass ejection, or a CME, a plume of plasma and magnetic field. According to space weather forecaster Sarah Hassel post on X, and as expected with the return of many regions, big solar flare activity also has returned. AR3869 wasted no time with going straight for an X3.3 flare earlier today with a large CME. These regions will need to be watched over the coming days as they rotate westward and face Earth. When CMEs hit Earth, they trigger geomagnetic storms like the ones experienced earlier this month that led to an impressive northern lights stretching to mid-latitudes, not to mention the southern hemisphere. But before you aurora hunters start getting too excited, note that it is unlikely any significant portion of a CME released during the event will impact Earth due to the position of the sunspot at the time of eruption. But as we are still awaiting CME models, we cannot say for certain that Earth won't at least receive a glancing blow. Watch this space, they say. Okay. It does continue on to say that space weather forecasters and aurora chasers alike will keep watching watchful eye on AR3869 as it crackles with solar activity. And there is just an image of where we're talking about on the sun this is residing, region 3869, which is slowly coming around towards our Earth-size view on our facing the Earth, that is to say. The article continues on to talk about a few other little things, like what are solar flares, in case you didn't know what they are. excuse me, solar flares are explosive events on the sun's surface that emit strong bursts of electromagnetic radiation. These flares occur when magnetic energy accumulates in the solar atmosphere and is rapidly released. They are categorized by intensity, with X-class flares being the strongest. M-class flares are 10 times less intense than X-class, followed by C-class, which are 10 times weaker than M-class. B-class flares are 10 times weaker than C-class, while A-class flares are 10 times weaker than B-class. Typically, have no noticeable effects on the Earth. Each class also has a numeral scale of 1 to 10 and beyond for X-class to further indicate the strength of the flare. Then you've got shortwave radio blackouts, which has a picture here to show. This one here. Shortly after the X-class solar flare erupted, shortwave radio blackouts were detected over Australia and the southeast Pacific. The sun-lit portion of the Earth at the time of the eruption. These shortwave radio blackouts are not uncommon during such explosive events and result from the intense burst of X-rays and extreme ultraviolet radiation emitted during the X-flare. Radiation from solar flares travels to the Earth at the speed of light, ionizing the upper atmosphere when it arrives. This ionization increases the density of the atmosphere, affecting high-frequency shortwave radio signals used for long-distance communication. As these radio waves pass through the electrically charged ionized layers, they experience energy loss due to more frequent collisions with electrons, which can weaken or even absorb the radio signals. So there it is. There's a quick description. All right, I'm going to now bring up Tamitha's little video. She's prepared for us here. And let's go for Tamitha. Do I have a little caption here thing? Yeah, I'll bring that up first. There it is. There she is. And I shall now queue up her video. There it is. And I think that's ready to go. And if I press this button here, we should be ready.
We have some fast solar wind, a slow solar storm, and a lot of flare potential on the east limb. Those stories and more in the news this week.